Welcome, dear students, to Dr. Babasaheb Ambedkar Technological University, Loneri. Myself, Madhuri Patil, Assistant Professor in Basic Sciences and Humanities Department, Marathwada Institute of Technology, Aurangabad, welcomes you to the lecture of Engineering Physics with Unit number 4, Crystal Structure, X-rays and Electrodynamics. What you will learn with this chapter is unit cell, Bravais lattices, cubic system, number of atoms per unit cell, coordination number, atomic radius, packing density, relation between lattice constant and density, lattice planes and Miller indices. Second part of this unit is X-ray, and in X-ray diffraction, line and continuous spectrum of X-ray, and at the last, introduction of Maxwell's equations. To start with the crystal, we must know some concepts. Then, for this, all the matter available in the world is in either of the following states. Yes, you know these states very well, which are solid, liquid and gas. Of these, for crystal, we require the concept of solids, the one that is limited by form, shape, size, sound and color is called solid. If you see in the figure, you are observing that there is a structure of a cube and a prism. One is cubic in shape and another one is triangular in shape. So from this we come to know that these are the solid structure and they are having their definite shape and their size. The solids are classified as crystalline solids and amorphous solids. The solids in which atoms are arranged in particular order with perfect periodicity. The word periodicity is important, and that periodicity is again over long range order. Such substances are called as crystalline solids. Next is amorphous. In amorphous solids, atoms are arranged randomly and they don't carry any periodicity and also not long range order. This we come to know if we observe these figures carefully. First is crystalline solid. It consists of atoms which are arranged in a particular order, while in amorphous solids the atoms are not having any periodicity and they are not arranged properly. The example for a crystalline solid is rock salt, while for amorphous solid it is a glass. With the help of these figures, you can understand very clearly what is the difference between crystalline and amorphous solids. Next is a crystal structure. To understand crystal structure, that is the definition for crystal, that crystal is lattice plus basis, or we can say lattice decorated with a basis or motif is called as crystal. Now what is basis? Basis is an atom or a group of atoms about lattice point constitute the basis or motif. Lattice is an infinite periodic array of points in space. It may be 1, 2 or 3-dimensional, in which every point has identical environment. This can be clearly observed with the help of this figure that consists of a basis and plus lattice, and both these together constitute a crystal structure. Next is unit cell. It is the smallest block or geometric figure of a crystal. With the help of unit cell, the entire crystal is built up by repeating it in all the three dimensions. It is also called as the building block of crystal structure. The geometry and atomic position determines the crystal structure. We can observe in the figure that it consists of three primitive vectors: A along x-axis, B along y-axis, and C along z-axis, and alpha, beta, and gamma are the angle between the three axes. So, in together, these three axes or three vectors and three angles are the total 6 lattice parameters. These unit cells, they are again classified as primitive and non-primitive unit cells. Then first, the primitive unit cell or just a primitive cell. It is the simplest type of unit cell that contains only one lattice point per unit cell at its corner only, and its example is simple cubic. See the figure. Here we are observing that there are 8 corner atoms at the corner of this cube. Then such structure is called as primitive unit cell. Then non-primitive unit cell. When there are more than one lattice point in unit cell, it is called non-primitive unit cell. It contains additional lattice points which may be on the face of the unit cell or within the unit cell. Its example are BCC and FCC. BCC and FCC are nothing but body-centered cubic structure and face-centered cubic structure. In non-primitive cell, in body-centered cubic structure, in addition to these 8 corner atoms, we are having one atom at the center of this unit cell. Then it is called as body-centered cubic structure. And in face-centered cubic structure, as per its name, in addition to these 8 corner points, we are having 6 more lattice points on the 6th face of the crystal or unit cell. This one lattice point is on the top surface. This is on the bottom surface. This is on the left surface. This is on the right surface. This one lattice point, it is situated on the back face, and this one is on the front face. Then such type of unit cells, they are called as non-primitive unit cell. Crystal systems. On the basis of shape of the unit cell, in terms of their axial length and interfacial angles, crystals are classified into 7 systems. These 7 systems are cubic, tetragonal, orthorhombic, rhombohedral, monoclinic, triclinic, and hexagonal. Now, how do they differ? They differ with their lengths and angles. A, B, C are the vectors, alpha, beta and gamma are angles. In cubic, all the sides and all the angles are same, and these cubic structures or crystals, they are of three types. Tetragonal. Tetragonal has two sides of same length. Third one is different, but all the three angles are 90 degree and they are of two types. Next is orthorhombic. In orthorhombic, all angles are same, but all the sides are different. They are of four types. Rhombohedral. Sides are same. All the three angles, they are also same, but the condition is that they are not equal to 90 degree. And this is the only difference between cubic and rhombohedral structure. In monoclinic, three sides are different. The two angles alpha and gamma, they are 90 degree but not beta, and they are of two types. Triclinic, as per its name, all the three sides and all the three angles, they vary. None is similar to other, and it is a single one. In hexagonal, two angles are 90 degree, third is 120 degree, and in sides, two sides are same, but third is different. It is a single lattice. If we add all these number of lattices, we get 14 Bravais lattices that we will see in the next lecture. Now this is the link for quiz. Please attempt this quiz so that you will come to know how much do you understand. These are the references. Thank you.